Hello everyone, welcome to the next A to Z webinar on making associative 3D finite element models. Okay, so when you're doing a 3D finite element analysis, you pretty much always start with a 3D CAD model, either something you model yourself or something you receive from a customer or another part of your company or whatever. Now, the whole key to this is that you don't want to have to redo any of your geometry simplification or whatever you need to do to get the 3D model ready for meshing after a change has been made to the original model. So I'm going to show you how to do all that stuff. Alright, so here we have a 3D CAD model. It's a simple linkage. And we're going to do a 3D finite element analysis on this part. So we switch to advanced simulation and then create a new FEM in simulation. That brings up the new FEM in simulation dialog box, and this is basically just asking what kind of analysis you want to do. That's down here, and then it's asking you how you want to set up the analysis. So it's going to make a .fem file and a .sim file. .fem is the finite element model. That's what FEM stands for. Inside this file, that's where the meshes are, and also the material properties typically. Inside the sim file, that's where the loads and boundary conditions are, and all the different solution options for how to run the analysis. This section here is how you want to handle the geometry simplification and what CAD geometry you want to use and all that kind of stuff. So the key to this whole thing is making an idealized part, and the idealized part is kind of an intermediate part where you're actually going to store all your geometry simplification. The only time you wouldn't create an idealized part is if the CAD model was created specifically for meshing. So if you actually modeled something specifically to create a mesh, then you don't need an idealized part. But because this is a CAD model, it's a final design type model, we need to make an idealized part. And then geometry options, you can use this if you want to bring curves and other things like that into your finite element model. So we don't need any of that. We just want the CAD or the 3D geometry. If you have multiple bodies, you can just grab them all. You can select them or whatever you want to do. Okay, so we'll make the FEM and the sim file. It's going to throw us into the simulation file. So you can see we're in the sim file. This is the solution options dialog. It's asking us just to set up the solution, what kind of analysis it's going to be. We picked Nastran, so we have all the different Nastran solutions here, and then all the solution options. We're not going to worry about that right now, so we'll just accept the defaults to get out of there. And then we pop over to the simulation navigator, and here's all the parts that we just created. We created this idealized part file, the FEM file, which is where the meshes are going to be stored, and then the sim file. And then beneath all that is the original CAD file. So because of the way this is structured, you can have multiple idealized part files linked to one CAD file, multiple finite element models linked to one idealized part, multiple sim files linked to one FEM, and that allows you to not have to redo anything if you need to do a different type of analysis. So you can just jump back to the FEM file and create a new simulation, and if you want to run a different type of analysis or try different meshes, you can use your idealized part file to create different meshes from, all that kind of stuff. Okay, so this is about simplifying CAD geometry to get it ready for meshing and maintaining a link between the original part and the simplified part. So we're going to make this the displayed part because that's where we're going to be doing our work. And the icons here, you notice, it's just kind of, simplified part is just a block. The original part is a block with blended corners, a hole. So just kind of a little bit of graphical recognition, I guess. Alright, so we're in the idealized part, and if you jump to the assembly navigator, you notice this part is now an assembly part, and the original part was brought in as a component. And you jump to the part navigator, you see there's nothing. So there's no geometry inside the actual idealized part. There's just one component, one assembly component that was put in here automatically when the file was created. Now, normally when you make the idealized part, the displayed part, NX will give you a message saying that you need to create some wave-linked geometry to do any kind of editing, do any kind of geometry simplification. So I didn't get that message because I told NX I didn't need to know that anymore. So it doesn't show that message anymore. But basically what's going on is, if you want to actually make any changes to this geometry to mesh it, you have to make a wave-linked body, because you can't make changes to an assembly component from inside the assembly. You have to make the changes to the actual component, and we don't want to do that. So we're going to do the wave geometry linker. We're going to do a linked body. Now if you jump to the part navigator, you see I've got this linked body, and you can see it overlaps the assembly component perfectly, so that's why you get these sort of overlapping faces and all that. So we're not going to do anything with the component, so I'm going to turn that off, and then I'm going to change the color of the linked body so that I know just by looking at it whether I've got the linked body or the assembly component. Okay, so this is my linked body. Now I can start making changes to this, because this geometry is now resident inside the idealized part file. The link to the original component is there, but what I can do is I can change this geometry, and it will actually kind of add these changes on top of the original component geometry. So geometry simplification just basically, more often than not, means deleting blends and deleting holes and that sort of thing. Other type of commands that you would use in this scenario would be splitting it up to do hex meshing, or doing mid-surface commands if you're going to do 2D meshes. All those commands are here. There's mid-surfacing, splitting, idealized geometry, and then there's the whole synchronous modeling tool set. So we're just going to look at a couple of these commands. So idealized geometry, this allows you to eliminate small features by size, which is kind of nice, right? So you just select the body, say I want to delete all blends that are less than 40 thou radius, and so that's it. Now we've got all the blends are gone, except for these blends on the end. They were a little bigger, so maybe for those blends we use a delete face command, and we get rid of those. Okay, so that's it. All our blends are gone. We could also do some more stuff, deleting holes and whatnot, but we're not going to bother with that. Just real quick on some of the other commands. The mid-surface command is really nice, and you can just tell it to automatically find the mid-surfaces. And you can see it went through and found all these mid-surfaces, extended the mid-surfaces to connect them to each other. And that is also a parametric, a linked parametric feature. So if you change the original geometry, these face pairs will update. And then of course splitting is also a linked parametric feature. Okay, so you've gone through and eliminated the blends that you needed to get rid of, and now you would switch to the FEM file and you would mesh this part. And the automatic mesher, you could just do a tet mesh and this would mesh in no time. Or you could do some splitting and do a hex mesh, whatever. But now, let's say, and obviously this simplification was pretty easy and not very time consuming, but as everybody that's done finite element analysis knows, sometimes you have to get, there's a lot of work goes into simplifying the body, the part, and getting it ready to mesh. And it's not a very happy situation when you have to start over and do it all over again because of some minor change. So if the original file was modeled in NX and the designer needs to make a change, and he would just make that change. Sorry, I gotta switch to modeling. Just make that change inside NX. And all these blends now, they go from 30 thou to 45. So that's fine. And then maybe, we got to move these bosses a little closer or something. So we'll just use some synchronous commands. And should we grab everything? So the bosses both move in a little bit and the blends get a little bigger. Just kind of a normal revision to a part like that. Okay, so the designer makes the change, lets you know, hey, I made this change, you need to rerun the analysis. Well, because everything is inside NX, all you have to do is just go back to your file and you've already got the updated geometry. So you can see there's an overlay now, the blend size updated, everything. So your linked body just automatically updated with those changes. You can see the delete face command is still intact because these blends are gone, but the idealized body command is no longer doing anything. And the reason is because we said that we wanted to leave blends under 40. Well, all the blends are now 45. So we just got to change this to 50. And it will delete all those blends again. So if you had used delete face on everything, it would have just come across and all the changes would have still been there. Any sort of synchronous technology, move face or resize or anything like that that you had done would have updated automatically. If the designer made drastic changes like getting rid of holes or something, and you had gotten rid of the same hole in your idealized part, then you would just see a feature over here that had an error because it was no longer valid, and you could just delete that and move on. Okay, so the gist of all this is make an idealized part, create the linked body, and then use synchronous modeling or some of these advanced simulation tools to do your geometry simplification, geometry editing, whatever. You can also use modeling tools in the idealized part, so if you need to make curves and points for concentrated masses or planes for splitting or whatever you need to do, you got the entire NXCAD tool set, and everything is going to stay linked and everything is going to update and all that good stuff. Okay, so let's say that the original file was not an NX file. It was a file that you imported, came in from the customer as a parasolid or as a step or whatever. So I'm going to undo these changes so we can get back to the original configuration. And I'm going to go back to the idealized part, change this back to what it was. Okay, so your original part came in as a parasolid or whatever, and you imported it into an NX file, and you went through the process of making the idealized part and all that good stuff. And then your customer sent you a new parasolid because they made some minor changes. And obviously you don't want to have to redo all your simplification. You'd love to be able to just somehow get NX to recognize that the new parasolid is in fact just a minor revision to the old file. And the way you do that is with the wave geometry linking replacement assistant. So I'm going to make a new file, and I'm going to bring in a parasolid. And this is a part that I made. I just made some minor changes to my original part, and I exported a parasolid. So it's going to come in, and now there's no link at all between the original file and this file now, because I've exported it and imported it back in, and doing that, the link is gone. NX doesn't have any idea that this is just a minor revision to an existing part. So inside the idealized part, by the way, this process works for CAM and drafting, and anytime you use wave geometry linking to create these linked copies. Alright, so inside the idealized part, I'm going to delete the original part from the assembly. I'm going to delete the component, and then it's going to tell me that there was a broken link, so my linked body is broken. And if you don't want that, you need to do an undo. I do want that. I want to break the link. And then I'm going to bring in my new one. Alright, so it comes in. You can see that I've got these, the blends are, if I just make this the current feature, you can see the boss has been moved in the new part. The new part is orange, the old part is green. The boss has been moved, the blends are resized, all that stuff. Okay, but I want to transfer all my edits to the new part. I don't want to have to redo them. In this particular case, you may just want to redo them because it takes 5 seconds. But if you had a lot of work into it, you wouldn't want to redo everything. So what you can do is open up the linked body, select the new part, and then open up the replacement assistant. Okay, so what you can do here is you can do a geometric comparison between the new body and the old body. And you specify the deviation tolerance and tell it to geometrically compare the two and look for matches. So right now it's analyzing the new part and the old part. And it found 218 matching faces. So that's pretty good. Everything in yellow, it matched. But we still missed quite a bit. Now at this point you could start manually matching them. You could just select a face over here and select a face over here and match them up. But what I'm going to do first is I'm going to increase this tolerance a little bit, because I know that if I increase it to even 20 thousandths of an inch, I'm probably not going to get extraneous matches. So I'm going to increase it to 20 thousandths. Alright, now we're getting really close. So it pretty much matched up everything except these outside blends and then the bosses. So at this point, I think I'm just going to manually tell it what's left to match. Alright, so I go into current activity, make sure manually defined matches is selected. The reason the two views are moving together is because I've got synchronized views here. So the views move together, which makes it really easy to select the matching faces. So I'm just going to pick the faces and then add a new match. And once I've selected add new match one time, then I can just do the middle mouse button and it will do that for me. I'm going to change this to face too, so I don't inadvertently grab any edges. And because everything that we did was on faces, you know, delete face and idealize body, and then all the synchronous modeling tools are all face driven. So you don't have to worry about picking up the edges that NX didn't you know, automatically match up. If you just get the faces, any sort of synchronous commands that you did will carry over, you know, the splits and stuff, and mid-surface is a face thing. So all that stuff will carry over if you just match the faces. So that alright, let's just stop there and we'll see if it picks up one half of it, not the other. Alright, so we did the replacement assistant, we matched up all the faces, and now it's transferring the features over. Turn that off. Alright, so now we're just looking at the linked body, and you can see I still have to go back in here and update this to 50 because all the new blends are 45. So that takes care of that. And notice my delete face, it worked on this side but not on this side because I didn't manually match these faces. Alright, so if you're using an NXCAD file, this all just kind of happens for you as long as you do the idealized part and a wave-linked body. If you're importing geometry through one of the file, you know, the universal formats, step, parasol, whatever, then you still do idealized parts, wave-linked bodies, and you can use the replacement assistant to tell NX what matches up between the old part and the new part so that you don't have to redo a bunch of stuff. Okay, so that's it. Thanks for your time. I hope you learned something, and I'll see you next month.